Welcome to the course of wireless sensor networks. Today we will be discussing about network layer, particularly the routing matrix and flooding and the concept of gossiping in a network. And this is lecture number 15, and this will be the part 1 of our today's lecture. I am your instructor Zeeshan Bangash. So network layer is one of the most important layer of a network model, and any type of congestion or the intelligent decision for any network that took place on this layer. So let's move to the agenda item of our today's discussion. So today we will be discussing some background about this particularly network layer, and then we'll try to classify different routing protocols that are part of this layer. Uh, we will be discussing some data centric protocols in our today lecture, like the spin protocol, the flooding and gossiping mechanisms, the mechanism of the direct diffusion, which is one of the most important mechanism in a communication, and then uh, a topic that is related to a rumor routing, and at the end we will summarize our discussion. So let's discuss the background, keeping in view the basic knowledge of the communication from the course of data communication and networks. We already know that the OSI model that comprise of 7 layers, with the first and the bottommost layer is the physical layer that comprise of the hardware, and the topmost, which is the application layer, that comprise of some services with which the user interact. So similarly, if we consider the wireless communication model or the WSNs model or the advanced networks, so this layer model, this 7 layer model, is somehow or the other implemented in the form of some architecture. So as we already know from the uh, background of our course, data communication and network, that the layering model has been introduced, or the standardization has been done, so that every layer should be dedicated for a specific task. So the different layers we discussed in OSI model were the physical layer, that is the layer number 1, and then the data link layer, and then the third layer, which is the network layer, which is our today's discussion. Part of this layer will be discussed in our today's lecture, and then the fourth layer, which is the transport layer, followed by session layer, which is the fifth layer, followed by presentation layer, which is the sixth layer, and then at the end we already discussed about the application layer. So sensor nodes, they are basically a tiny nodes or a tiny computation device that is placed at a very uh, different environment than a communication computer or a communication normal node. The routing mechanisms changes with respect to the time, because the nodes or the small tiny device, first of all, they are deployed in bulk. They are deployed in thousands, and then thousands at different locations, and then based on the availability of that, or the liveliness of this node with respect to the time, because the network lifetime will spread over months and years. So some sensors in the bulk deployment may maybe communicating, some may be dead, some may be damaged. So the whole network topology changes with respect to the time. And similarly, we cannot fix any routing mechanisms or any routing table for an entire period of time. So there's very much dynamism if we consider the routing scenario in case of the sensor node. They are very limited in computation power. They have very limited uh, processing capability, and they are very limited in uh, in 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 memory as well. So these are some of the challenges that needs to be considered whenever we design an application, keeping in view when we design any application for wireless sensor network. If we are going to consider the network layer of the node, because we will not be involving these small nodes to be engaged in too much communication. The routing table which will be designed needs to be very lightweighted, or if they are communicated among the neighbor nodes, so the normal flooding should be optimized. So these are some of the mechanisms that needs to be considered. Similarly, the most important aspect is the bandwidth or the energy constraint. Since these are very limited in energy, and uh, in case of flooding or communication that is taking place, so that energy can be exhausted in a couple of minutes or in a couple of hours. So we want these network to observe these type of networks or these small nodes to observe any phenomena over a couple of months or years. So these nodes needs to be live, and they should rely on the energy, whatever energy they have at the time of the deployment. So we need to optimize the consumption of the energy. So this is another challenge we already discussed. And then the most important mechanism is the optimization of whatever data that have been sensed through the mechanism of data aggregation. So this data aggregation, whether it's to be performed on every sensor or some part of that aggregation, or there needs to be some focal points on which the sensor moves that data, and that data is aggregated there, and then an optimized form or summarized form is moved to some other or upper layers. So we have already discussed about the um data aggregation mechanisms. Now since it's basically the application are very much specific to the scenario or the phenomena. So and there is also an integration till this time with the internet, so there is no global addressing mechanisms. And then there are sync nodes. They are more powerful nodes, we already discussed that. And then there are gateway nodes through which the network is connected to other nodes. And then there is mechanism, because these sync nodes usually provide the gateways. They are either connected to the internet or the wired network, and they are basically the main source of data collection point from where maximum processing is performed, because they are a bit rich in energy and the computation and the memory perspective. So we already know that. So the goal of our today's discussion is that at the network layer we need to find methods uh, or mechanisms so that the energy may efficiently may be used in case of the routing or the route discovery. Similarly, at the network layer, the purpose is basically to relying of data from sensors node to the sync level, so that this will help to increase the lifetime of the network, or the sensor will be live for a long duration. That will help us not to redeploy and reconfigure the network in case the sensor node are exhausted due to over computation or due to more computation. So the goal of basically this layer is to make that network energy efficient. So let's discuss about some of the routing protocols. So it have been the routing protocols in wireless sensor network are basically categorized into a network structure and the protocol operations. So you can just look at the figure in which the hierarchy or the routing protocols in WSN has been shown. Uh, so let's discuss about the data centric protocol. So the first is the flooding and the gossiping, and it has got the ability. This protocol has got the ability to query a sensor or a set of sensors, and an attribute based naming mechanism is used in this type of data centric protocol. And uh, during the process of relaying in flooding and gossiping, the data aggregation is performed at the same time. An example of such flooding and gossiping protocol or the data centric protocols that includes the spin protocol, the direct diffusion, and the rumor routing protocols. So let's talk about some of the pros of this specific type of protocol that's very simple. And we can say that it cannot help so much in routing since it cannot maintain the state. So this is the limitation. And if we consider it as a simple, so it will be using less computation, but if in case of effectiveness for routing data so that it can be reached in a limited time, and if we following a short path, so it is not so much effective in that terms. And some of the cons of this type of protocol is that it's very expensive in terms of using resources. It's very implosion, it overlaps the mechanisms, and it allocates resources blindlessly. So this is also again an overhead if we consider the very limited resource constraint, and the whole network will be delayed. So a delay is formed if we are using this type of protocol, so a delay is imposed. So these are some of the drawbacks of this type of protocol. However, the advantages is that it's simple. It can be implemented with little effort. The another protocol is the sensor protocol for information while negotiation, and which we call it a spin protocol. It basically negotiate between different sensors metadata, uh, and then it follows. Already we have discussed in the previous lectures that a three-way handshake. There's the EDV request, then the REQ request, and then a data is transmitted. So a three-way handshake took place. And secondly, this is an event-driven protocol. You can just see in the figure shown on the slide that an ADV request is sent from the sender, and then upon the receive a reply is sent, and thereafter the data is transmitted from that central location B to different nodes, as you can see in the diagram that has been elaborated. Now, some of the advantages is that the classical problems which we observe in the traditional network related to optimized routing, that is addressed in this sprint protocol. And similarly, whatever topological changes happen, these topological changes are localized in that network. So it's not this spin protocol is effective for a localized topological changes. However, it has some drawbacks too, and the drawbacks includes that the data that is to be delivered to from a source to a destination, so it have no guarantee. So there is no acknowledgement type of mechanisms. Then the direct diffusion, which is another data centric protocol, and the sync node basically floods interest with the large updated interval, and the sensor nodes that sends back data via gradients that have been defined, and sync nodes that sends the same interest with smaller update interval. it's not an event driven, but it's a query driven protocol. As we discussed that the sprint protocol was an event driven, an event occur and then it performs. It's basically a query based or a query driven protocol. And you can just see the diagram that at the first phase, from the source, an interest is propagated into the network, and then after the interest is propagated, a setup, initial gradient setup has been taken place, and then thereafter the data in the third phase is delivered from the source to the sink. Some pros include that the routing is performed on demand, so it's a sort of on demand setup type of mechanism, and the every node performs aggregation and caching, so that will be using a lot of resources. Thus we can see that as a positive aspect, that the computation has been distributed into multiple sensors. Every sensor do aggregation, and it will introduce low delay. Similarly, some disadvantages include that in case of a real time or a continuous type of data delivery, this protocol is not suitable, since it's a query driven protocol, and it involves an extra computation computation overhead in data matching and queries. That's an extra overhead for this type of protocol. So another protocol that is a data centric protocol in the network layer is the rumor routing. So there is a trade-off that already exists between a query-driven, which we have already discussed in the data diffusion protocol, and an event-oriented protocol, which we discussed as the sprint protocol. So an agent that needs a long-lived packet needs to be generated whenever an event that needs to happen. So here there is a long-lived packet generation mechanism. This agent is propagated that propagates this event to different nodes, and this mechanisms this rumor routing has an edge over the data diffusion protocol, that it avoids the query flooding, as we see that there is a lot of flood in the flooding mechanisms that can make a congestion in a network in case of data diffusion protocol. So in rumor routing, that query flooding can be avoided. However, it has some drawbacks, and these drawbacks are that this protocol is very much effective if the number of events that happens in a network are in a small number. So it is very effective. It will perform optimized operation, and it will consume less resources, and it will help the network to be live, or help the sensor to be live for a long period of time. However, there is always some complex event tables that are generated in this type of network, and managing these tables, updating these tables, storage of these tables is again an issue. So this is a memory resource constrained issue. That is one of the drawback of this type of data centric routing protocol. So another protocol is the hierarchical routing protocol, where sensor density that is increased with every tier network causes. So it is a gateway overloading protocol, and this hierarchy increase the delay, it increase the latency, and it is a very energy consumed oriented protocol. So cluster network are basically a choice of most of the researcher, but when we consider it for wireless sensor networks, so they are always a resource constrained network. So cluster network allow the coverage of large area of interest, and additional load with degrading that will be degrading the performance of that network. So idea is basically the partition the complete network into some clusters, and then select one of the node as the head node, or the cluster head node. The routing node is thus the cluster head A, and the cluster head B, and the cluster head C. So every type of network in that cluster have passes through these routing nodes, and the routing between cluster head and the routing within the clusters may follow the OSPF or the BGP, which is a traditional routing protocols for wide area network, for inter wide area network communication. So that these protocols can be implemented on the cluster heads, and we can process the traffic. However, this some issues resolved using this protocol as that energy wastage happens in the collision, so the collision avoidance needs to be considered, and then there is an ideal listening mechanism that needs to be avoided, so we can achieve a good feasibility in case the network grows or the network is very large. And it can help us that with using this protocol, that load on the nodes which are less in power can be removed. So this is the end of our today's discussion, which is part one of the network layer. So this is the reference from which the content has been taken, so you can consult it, and other material will also be shared on the WhatsApp groups as well. So with this, thank you very much for patiently listening. Take care. Allah Hafiz.